suppose we have a student who lives by himself. In other words, he lives away from the parents, and he decides to document his consumption in terms of breakfast, lunch, and dinner over the weekends. So the first week he starts to document that. He realizes that on Saturday he spent 120 for breakfast, 200 for lunch, and 180 for supper or dinner. On Sunday he spent 110, 150, and 130 respectively. The second weekend he realizes that on Saturday he spent 150 for breakfast, lunch 230, and dinner 200. On Sunday, it's like he did not take anything in the morning, but at lunchtime he spent 150, and during dinner he spent 170. And on third weekend, he spends 70 for breakfast on Saturday, 100 for lunch, and 80 for dinner. While on Sunday, same weekend, he spent 110 for breakfast, 150 lunch, and 220 for dinner. So as the days go by, he may decide to document the figures without including the titles breakfast, lunch, dinner, or even the days of the weekend. So, for example, if the following weekend he documents this way, he can easily remember that this one represents Saturday and this one represents Sunday, and then this is for consumption over breakfast or during breakfast, and this lunch, and this is dinner. So he can continue documenting time and again without inclusion of this, and he can easily identify what a particular figure represents. Now, if he decides to include brackets or to enclose this information in brackets, then what we come up with, or what we will come up with, is what we call a matrix. We can define a matrix as a rectangular arrangement of numbers and sometimes letters enclosed in brackets. The horizontal set of numbers like 140, 180, and 210 in this case form what we call a row of a matrix, while the vertical arrangement of numbers like 140 and 55 or 180 and 300 in this case form columns of the matrix. The individual numbers that form the matrix like 140, 300, 250 are what we call elements of the matrix. Now, elements of a matrix are normally identified based on the row they are on and the column they are on also. Like in this case, element 3 is in the first row, which we call row 1, it's in the first column. Therefore, we say element 3 is in row 1, column 1. Element 11 is in the second row and then in the third column, and therefore we say 11 is in row 2, column 3. That's how we identify elements in a matrix. Size or order of a matrix refers to the number of rows and columns in a matrix. Like in this case, this matrix has 2 rows, 1, 2, and then it has 3 columns, 1, column 2, and column 3. There are 3 columns. Therefore, we shall say this matrix is of order 2 by 3. A zero matrix is a matrix which has elements consisting of zeros only. You can see this matrix here has elements which are zeros. There's no any other number apart from zeros. In that case, we say this is a zero matrix. Now, for the case above, you see not all elements are zeros, and therefore you cannot call this one a zero matrix. A square matrix is a matrix having equal number of rows and columns. Like it can have 2 rows and 2 columns, or 3 rows and 3 columns. A good example is this one because it has 2 rows and 2 columns. So it's a square matrix. But the one above here has 2 rows and 3 columns, meaning the number of rows are not equal to the number of columns, and therefore we cannot say that this one is a square matrix. And primary diagonal refers to the set of elements from top left to bottom right in a square matrix. So if we take this example here, the set of elements from top left to bottom right refer to these elements 1 and 5. So they form elements in the primary diagonal. For this square matrix, the elements in the primary diagonal are A, 18, and -2. They form elements in the primary diagonal. While this other diagonal, consisting of elements 11, 18, and -4c, form elements in the secondary diagonal. For this case, the elements in the secondary diagonal are 0 and 3. An identity matrix, which we also call a unit matrix, is a matrix which has elements in the primary diagonal being 1s and the rest of the elements being 0s. Like we can have a 1 here, a 1 here, and a 1 here. The rest of the elements are 0s. That will lead us to what we call a unit matrix. In this case, we need to have a 1 here and another 1 here, this and this being 0s. That's when we can achieve a unit or identity matrix. Those are the ones that we have here. Addition and subtraction of matrices. Matrices can be added or subtracted if they are of the same order. In other words, if the number of rows of the first matrix equal the number of rows of the second matrix, and the number of columns of the first matrix equal the number of columns of the second matrix. Example, suppose we have been given matrix A and matrix B, and we are supposed to find A plus B and also A minus B. So what do we do? The first thing we do is to test whether the matrices can be added or subtracted, and that's achieved by writing the order or size of the respective matrices. Now, when we talk of order of a matrix, it refers to the number of rows and the number of columns of that matrix. Taking matrix A, it has 1, 2 rows, so we write 2 here by 1, 2, 3 columns, so it is of order 2 by 3. This one has 2 rows and 3 columns, so it's also of order 2 by 3. So the two matrices are of the same order, and therefore we can add or subtract them. Now, coming to the first one, A plus B, it simply means you write matrix A, add to it matrix B. That is our matrix A plus matrix B. When you do that, then, now how do we add those matrices? We take an element and then add to it a corresponding element on the other matrix. In this case, we shall take 7 plus 1, then 3 plus 2, then 6 plus 10. Down here, we shall take 9 plus 8, then 5 plus 0, and then 4 plus 11. When you do that, you now simplify that. It will give you this as the answer. 7 plus 1 gives us 8. 3 plus 2 gives us 5. 6 plus 10 gives us 16. 9 plus 8 gives us 17. 5 plus 0 gives us 5, and 4 plus 11 gives us 15. That's how we add matrices. To get A minus B, you write matrix A first, then minus matrix B. That is equal to, so how do we work out this? You take this element minus the corresponding element here. So we have 7 minus 1, then we shall have 3 minus 2, and then lastly 6 minus 10 for the first row. In the lower row, which is the second row, we do the same, 9 minus 8. Now you can guess the remaining 2. You have 3 seconds to do that. Well, it's 5 minus 0, and then 4 minus 11. So once you have done that, then we simplify the matrix to what we have here. So 7 minus 1 gives us 6, 3 minus 2 gives us 1, 6 minus 10 gives us -4, 9 minus 8 gives us 1, 5 minus 0 gives us 5, and then 4 minus 11 gives us -7.